All right. So again, this is the Module 6 and 7 final exam review. This is question 15, which is the Ferris wheel question, which could be qualified as a trig graphing application problem. So we got a diagram off here to the right. A Ferris wheel has a center height of 30 feet and a radius of 26 feet. So the center right here is 30 feet. This radius is 26 feet, which means this radius is also 26, which means 30 plus 26. We're going to be up here at 56 feet. So what is the maximum height? 56 feet. Which means the minimum feet, if this is at 30 and we go 26 below, we're going to be at 4 feet. All right, so the starting position is when we're off to the right at 0 seconds. The furthest to the right and rotates counterclockwise. So we're going to be going this way, and it takes 48 seconds. So we start at 0, we'll go all the way around, and then we'll end 48 seconds later back in the same spot. Which means over here, 24 seconds in will be on the other side. And then that would be 12 seconds up here will be up top. And then, what is it, every 12 seconds, 36 seconds will be down at the bottom, and then 48 will be at the top. All right, so when is it at a minimum? 36 seconds. When is it at a maximum? 12 seconds. What is the angular speed in degrees per second? Well, we travel 360 degrees in 48 seconds. I'm just going to type that into my calculator to get the decimal answer. 360 divided by 48. We get 7.5 degrees per second. What about in radians? Well, same thing. We travel a full circle, 2 pi radians, in 48 seconds. I'm just going to leave it as that. 2 pi over 48. We could simplify it more. Don't worry about it. Radians per second. What about the linear speed? Well, that is going to be how far we actually physically travel. So we're going to travel the entire circumference in 48 seconds. The entire circumference in 48 seconds. So the circumference is 2 pi r. 2 times r is 52 times pi. We travel this many feet in 48 seconds. This one I am going to type into my calculator just to get an exact answer. We go 3.4 feet every second. That's pretty fast. All right, write an equation of the time. So we know the graph would look like this. Up here at 30, we have our midline because that's where the center is. We go 26 above, and we go 26 below. We start at 30, we end at 30. At 24, we'll be at 30 feet. We go up to 56, we go back to 30, we go down to 4, and then we go back, and we're going to keep cycling. That's just a sine function. So the amplitude is 26 sine. We'll work out the inside in a second, plus our midline of 30. Now the phase shift, we don't have one because we start with the midline crossing, but since the period is 48 seconds, and the equation for period is 2 pi over b, and we're using 2 pi because it wants us to use radians. So to solve for b, we get b equals 2 pi over 48. So 2 pi over 48 time. That's our equation. What is the height at 6 seconds? Exact and approximate. So let's just plug in 6 into here and see what we get. Height of 6. We get 26 sine of 2 pi over 48 times 6 plus 30. 2 pi, that'd be 12 over 48, which simplifies to pi over 4. after we simplify that out. Sine of pi over 4 is root 2 over 2. That would be 13, because 26 divided by 2. So we get 13 root 2 plus 30 height, feet. That is the exact, to figure out the approximate, you just plug it into our calculator and get the decimal answer. And we get 48.38. 48.38 feet. I'm going to pause it here just so I could let people into the classroom. But these next two are going to be pretty good. This one is going to be great. This one is going to be annoying, but we'll talk about it.